And you have your equipment, you saw your bill, so now you can, let's go back, big picture. You want to get the measurement of the energy. You want to find out exactly where the energy is being used, right? By now you know how to read your bill. But the bill is general. It gives you the total information about the whole facility. You know how to measure different things that have different effect on the energy consumption. And one of the other things that is very important coming to the picture is the building envelope. Okay? So the building envelope is going to give you information about how energy is being used and lost in this building. The lost part is the most important part. If I have a building that is old, lots of windows, the windows are single glaze, lots of heat loss, and this building is in middle of Minnesota or Michigan, right? I'm going to lose a lot of energy just because of the wall are thin and the glass are thin, right? In California, no, it doesn't matter. So in California, if I audit this building and I find all of the windows are single glaze, I'm not going to put a recommendation that you need to make this double glaze. Because it's a lot of money to spend, you don't gain that much. But if this building is in Minnesota, it's very important. You have to make it double glaze, right? So location of the building is very important. How many windows you have, how many doors you have, what is the insulation status. A door is never sealed completely. There is always air coming. There is always air coming underneath here, right? You can never have a sealed door. A sealed door is a door that is never open. Right? And that's a huge loss. If you are dealing with energy auditing of a commercial building, a hospital, a mall, this door is constantly opening, closing, right? If you sit down for 1 hour, record the number of the time that this is being closed and open, you will see 90% of the time this door is open actually. That's a huge amount of the air that is coming. But how to calculate that? You have to count for this. Because the amount of the air that is coming, it has to be compensated. The building by itself, depending on what orientation it's facing, it's during the summer and winter time is going to be different. In the winter time, you're basically losing the energy to the outside because you're increasing the temperature in the inside. Outside is cold, it goes out. The energy that you lose brings the temperature of the room lower. When the temperature becomes lower, your thermostat kicks, your HVAC is going to work, right? So you pay for it. Summertime is the other way around. You want to keep the place cool. Outside is hot, so heat is coming in, gradually heat up the place. Your thermostat kicks in, your HVAC is working until the temperature reaches the level you want, and the cycle continues, right? So how can I minimize this exchange of energy? Sometimes actually it's not a bad thing. In winter time, I can use really the amount of the energy coming from sunlight in order to warm up my room, right? Orientation of the windows, orientation of the building, those are the things that are very important on that. But you have to make an engineering or calculated decision. Good example is that I have this big room, and in order to use the sunlight to warm up the place, I'm going to add a skylight to this room or to my house, right? So I'm going to get tons of energy coming in the winter time, and the room is going to be hot now. So it's going to cut my gas usage. Great. And you can calculate that. But now, what you have to deduct from your energy saving calculation is in the summertime, now you've got to have HVAC working. So you've got to pay for the electricity extra. So that's the deduction. But there is addition. Because of the sunlight that is coming, I use less electricity for my lights. So that's a positive. I'm going to take it out. So at the end of the day, positives, negatives, you balance it out. If you're living in Michigan, don't add the skylight because your bill for winter is off. Right? Living in California, It's a good idea to do that depending where you are in California. If you're further in San Diego, your summer bill is going to kill you because of the electricity of HVAC. If you're further in North San Francisco area, that's a good idea. It's not going to get that hot in summer. Right? You have to do a calculation. You cannot just come and make a decision that let's add a skylight here, I'm going to get a lot of light. Right? Always be aware of what's going on, what are the consequences around it. Infiltration is a very important factor in basically your energy usage. Let's assume I have this room, the heater is working, the temperature is a perfect 76 degrees Fahrenheit, sorry. Right? I turn off the unit, right? So it's at 76, it's perfect. I turn off the unit. I come back 5 hours later. What's the temperature? And it's winter outside. The temperature is going to be less, right? Because you're losing energy. You're losing energy through the wall, you're losing energy through the window, you lose the energy through infiltration, you have all kinds of cracks on your windows, on your doors, and everywhere, right? And you have to count for all of those things. For infiltration, it's very easy to calculate. If you know how much cubic feet per minute you're losing air or you're adding air, and what's the temperature difference between inside and outside? So in summertime, you're adding heat. In winter time, you're cooling down the place. Multiplied by 1.08, it gives you the total amount of power that you're losing as BTU per hour. Right? Now, you might say the delta T is easy because I know what's the temperature outside, I know what's the temperature inside, those are things are recorded very easily. What about CFM? How do I know how much air is coming underneath of that door? Nobody knows how much door is coming. Door is closing, the door is opening, it's going to change everything. So that's why what they did was, in the industry, they did a lot of experiments. They did a lot of measurement. And they try to come up with charts, depending on what kind of doors you're using. This is a sample chart. How many hours this door is open in average, and what's the total area of the door, and then it gives you the total BTU per hour that you're losing because of the infiltration. Most of these things are in different energy management handbook. It's easy to read. These are the charts. There are scientific calculation behind it also to back it up, but it's very easy to basically read this thing. Okay, in this example, I have, I'm trying to do energy audit on a building, on a warehouse. The temperature of the warehouse is supposed to be 65 degrees Fahrenheit during the winter. And it has 3 doors. Each door is 10 by 10 feet. These are the forklift doors, right? These are the factories. The forklift is going and moving, so these doors are keep opening and closing basically. The warehouse is used 24 hours, 6 days per week, and the doors are open 8 hours per day. So this is the average open. Average ambient temperature during the heating season is 48 degrees Fahrenheit. And these holes that are 10 by 10 is always open. The forklift goes, come back. Somebody came with this idea that says, why don't we basically hang some vinyl on it? You see, there are places that they have vinyl, plastic vinyl that is hanging, and when you go through them, and they are shredded, you can easily go and come back, they don't stop you. But somebody came and said, if I do that, I'm going to save energy. The cost of installation of those vinyl is $2,000, and the cost of the energy is $4 for every million BTU, with the boiler efficiency of 65%. So let's see how much energy I can save. If you go back to the figures that I had here, and basically for the door that I was using, which was 10 by 10, which is 100 square feet, operation hours is 8. I go straight up until I hit the 100, and I come here. This gives me 600 BTU per year. And that's the 600 million